Bismillahirrahmanirrahim. What is momentum? Momentum basically is the quantity of motion a body possesses due to its mass and velocity. It means that if a body is moving with a certain velocity, then you can multiply the mass of the body with the velocity of the body, then the resulting quantity is called the momentum of the body. We can write down the formula according to this, that momentum is equal to mass multiply the velocity of the body. Normally, symbolically, we represent momentum with small p and mass with small m and the velocity with small v. Then symbolically, we can represent the formula of momentum like this, that p is equal to m dot v. Now, as far the unit of the momentum is concerned, its unit is depending upon the mass of the body and the velocity of the body. If we take the unit of mass kg and velocity meter per second, then the unit of momentum will be kg meter per second. We can also write down the unit of momentum as Newton dot second, not Newton per second. Remember this, it is Newton dot second. As far you know that velocity is a vector quantity, so momentum will also be a vector quantity, and you also know that if a body is moving, definitely there will be a direction of motion of the body, and hence momentum is also a vector quantity. Now we have to consider the relationship between force and the rate of change of momentum. For this you have to consider a body of mass m which is moving with initial velocity vi, I for initial. Now here the mass of the body is m and the initial velocity of the body is vi, I for initial. Now a force is applied on the body. When the force is applied on the body, its velocity changes from initial to the final. So here initially the velocity of the body was vi, and after the application of the force, the velocity becomes vf, which we can term as final velocity. Okay, so the final velocity has become vf, and you know that whenever there is a change in velocity under the application of a certain force, this change takes some time. So that time interval can be represented by small t. Now we are clear that there was a body of mass small m. Initially this body was moving with initial velocity vi. A force is applied on the body, and then under the application of the force, its velocity becomes vf during the time interval small t. Now as you know that the momentum can be calculated with the formula that mass into velocity. So we are going to find out the initial momentum of the body, because initial velocity of the body is vi. So initial momentum, which is represented by pi, I for initial. P is representing the momentum of the body, pi initial momentum is equal to m, the mass of the body, and vi is the initial velocity of the body. So this is the initial momentum of the body before the application of the force. Now when the force is applied, the final momentum becomes represented by pf, final momentum, f for final. So this final momentum is equal to m into final velocity vf. So this is the final momentum of the body. Now the change in momentum, we have to find out the change in momentum. So change in momentum is equal to final momentum minus the initial momentum. Pf minus pi is equal to mvf minus mvi. So this is the change in momentum, which can be represented with the help of this equation. As I told you earlier that this change in momentum is occurring during the time interval small t. So dividing both sides by this equation small t, I have divided this equation by small t. So after doing this, I have taken small m as common. Within the bracket, I left final velocity minus initial velocity divided by time. So this vector, change in velocity divided by time. As you know that change in velocity divided by time is called the acceleration of the body. That is, rate of change of velocity is called acceleration. So acceleration is equal to final velocity minus initial velocity divided by time. So instead of writing this complete rate of change of velocity, I have represented it with small a acceleration. And you also know, according to the Newton's second law of motion, that F is equal to ma, F is equal to ma. So instead of ma, we are going to represent F. So instead of this ma, I have replaced this ma with F. So because F is equal to ma. Okay, now on the left side you can see that this is the rate of change of momentum. On the left side, rate of change of momentum is equal to F, the force applied. So under the application of the force, we can say that there is rate of change of momentum.